This one line of code destroys your memory and makes your senior developers cry, unless you know the Python performance secret hidden in parentheses and curly braces. We're diving deep into tuples and sets, the data structures you didn't know you needed, but that hold the key to writing blazing fast, high-efficiency Python.
You know, lists. They're flexible. They're the vending machines of Python. You can take things out, put new things in, swap items instantly. But that flexibility comes at a massive cost. Meet the tuple, defined by parentheses. This is not a vending machine. This is an engraved stone tablet. Once the data is chiseled into a tuple, it is permanent. This concept is called immutability. Try to change an item, and boom, error. Why would we want this restriction? Because the instant Python knows the data will never change, it optimizes the living daylight out of it. Tuples are faster to iterate, they are safer in multi-threaded environments, and most importantly, they are hashable, meaning they can be used as keys in dictionaries. Lists cannot do that. Tuples are the foundation of Python performance.
The single most satisfying piece of Python syntax, powered by the tuple, is unpacking. Watch this ancient ritual. If you wanted to swap two variables in old languages, you needed a temporary third variable, right? Gross. Python says, hold my beer. With tuple unpacking, we can swap variables in a single beautiful line. The variables on the left are implicitly assigned to the corresponding elements on the right. This isn't just swapping. This is how functions return multiple values, and it makes your code incredibly clean. It's elegant, fast, and makes you look like a genius.
Okay, hold on to your hats because we are transitioning from structured permanence to pure, unadulterated uniqueness. Meet the set, defined by curly braces, just like dictionaries, but sets only store values, not key-value pairs. What is the superpower of the set? It absolutely refuses to tolerate duplicates. If you feed a set 10,000 items and 9,000 of them are duplicates, the set will instantly and brutally delete them, leaving you only the unique items. No loops needed, no conditional checks. It is the fastest way to deduplicate any collection in Python. If your data processing scripts are slow, I guarantee you're not using sets. Sets let you perform high-level mathematics with data using incredibly simple operators. Think back to Venn diagrams in school. Sets make those diagrams runnable code. We have two sets of users, developers and managers. I want to know everyone who is either a developer or a manager. That's a union using the pipe operator pipe. Now, the challenge. What if I want to know only the people who are both developers and managers? That is the intersection. Take a guess what operator we use. Is it plus, and, or star? If you guessed and, the ampersand, you nailed it. This level of complex data filtering, which would take multiple loops and complex logic with lists, is done instantly with a single character. This is why data scientists live and breathe set theory. Sets are amazing, but they have a fatal flaw rooted in the same performance secret as tuples. Because sets need to quickly check if an item already exists, which requires hashing, the items stored inside them must be immutable. What happens if we try to put a list, which is mutable, inside a set? It throws a type error. Why? Because if the list could change after it was put in the set wouldn't be able to reliably locate it again. The rule is simple. Sets can only store hashable items. This means strings, numbers, and critically, tuples are allowed, but lists and dictionaries are forbidden. You now know the difference between data that must be flexible, lists, data that must be permanent, tuples, and data that must be unique, sets. Stop wasting processing power. Choose the right tool for the job. Your code will be cleaner, faster, and your senior devs will be impressed. Now for your challenge. Use tuples and sets together to solve the unique words finder. Take a long string of text and figure out the total word count and the total unique word count in the most efficient way possible. Post your solution below. Hit that like button, subscribe for more speedruns through advanced Python, and I will see you in the next video. Keep coding.